CE 8502 Structural Analysis 1 Slope Deflection Equations prepared by Anand A. AP Civil, Rohini College of Engineering and Technology. So first introduction, definitions, slope equations, general procedure for analysis the beams and frames. Let's see one by one. Slope deflection method. It is the exact method to find the forces, reactions, stresses, bending moment, shear force, and rotations. The slope deflection method is a structural analysis method for beams and frames. So, introduction of slope deflection. In 1915, George A. Manning introduced the slope deflection method as one of the classical methods of analysis of indeterminate beams and frames. The method accounts for flexural deformations but ignores axial and shear deformations. Thus, the unknowns in the slope deflection method of analysis are the rotations and the relative joint displacements. For the determination of the end moments of members at the joint, this method requires the solution of simultaneous equations consisting of rotations, joint displacements, stiffness, and length of the members. So next, determinate structures. So in slope deflection methods, we are going to analyze the support moments in the determinate structures and indeterminate structures. So that is first determinate structures. Statically determinate structures are structures that can be analyzed by the sum of forces in any direction is zero. In regards to beams, if the reaction forces can be calculated using equilibrium equations alone, then they are statically determinate. Next, indeterminate structures. In regards to beams, if the reaction forces cannot be calculated using equilibrium equations alone, then they are statically indeterminate. Slope deflection equation. Slope equation is for member AB. MAB is equal to M of AB plus 2EI divided by L into 2 theta A plus theta B plus 3 del divided by L. And for MBA is equal to M of BA plus 2EI by L into 2 theta B plus theta A plus 3 into del divided by L, where MAB and MBA is final moments at the members AB and BA. M of AB and M of BA is fixed end moments. Capital E and I is Young's modulus and moment of inertia. Theta A and theta B is slope angles, and del is deflection, and L is length. So this is the deflection. So due to external forces in that slope deflections, due to its angles, we're getting the slope deflections. In first diagram, there is a rotations in anticlockwise M of AB and M of BA, and next by using slope angles, there is 4EI theta A divided by L, 2EI theta A divided by L, and the support is hinge support. In that area the slope will be there, and fixed support there will be no slope. And last diagram, the deflection 6EI del divided by L square at A point. At B point there is a del B 6EI del by L square, that is del is equal to del B minus del A. And next, procedures for the analysis of indeterminate beams. Procedures for analysis the indeterminate beams and non-sway frames by the slope deflection method. Determine the fixed end moments for the members of the beam, and determine the rotations of the rod if there is any support settlements. Write the slope deflection equations for the members, each moments in terms of unknown rotations. Write the equilibrium equations at each joint that is free to rotate in terms of the end moments of the members connected at the joint. Solve the system of equations obtained simultaneously to determine the unknown joint's rotations. Substitute the computed joint rotations into the equations obtained in step 3 to determine the members' end moments. Analysis of indeterminate frames. Indeterminate frames are categorized as frame with or without side sway. A frame with side sway is one that permit a lateral moment or a swaying to one side due to the asymmetrical nature of its structure or loading. The analysis of frames without side sway is similar to the analysis of beams considered in the preceding section, while the analysis of frames with side sway requires taking into consideration the effect of the lateral moment of the structure. So, and finally, the sign conventions. An end moment M is considered positive if it tends to rotate the member clockwise and negative if it tends to rotate the member counterclockwise. The rotation theta of a joint is positive if its tangent turns in a clockwise direction. The rotation of the chord connecting the ends of a member del divided by L. The displacement of one end of a member relative to the other is positive if the member turns in a clockwise directions. Thank you.